Hi everybody, today we're going to look at the test of two variances in Minitab. We're going to start with just finding a p-value. So in this example, we have degrees of freedom in our numerator as 3, degrees of freedom in the denominator as 14, and an F ratio of 2.448. We're going to find the p-value given we're doing a right-tailed test. In Minitab, I'll hit Graph, Probability Distribution Plot, View Probability. I want to switch the distribution to an F distribution. My degrees of freedom in the numerator is 3, in the denominator we had 14. On the options, we have a specified X value of 2.448 and we said we want a right-tailed test. This gives us a p-value of 0.1068. Let's do a full test now. A manufacturing engineer wants to compare the variability and part dimensions produced by two different machines. Smaller variances is preferred for quality control. Random sample of part widths and millimeters are collected for each machine. For machine A, 10 samples were taken where the sample variance was 0.015. For machine B, 12 samples were taken with a sample variance of 0.005. At the 0.05 significance level, is there evidence that the variability for machine A is greater than that of machine B? Let's first state our hypothesis. The null hypothesis is that the variances are equal, so sigma 1 squared is equal to sigma 2 squared. Our alternative hypothesis will be that sigma 1 squared is greater than sigma 2 squared because we're trying to test if machine A has greater variability than machine B. To construct our F ratio, we compare the sample variances, S1 squared over S2 squared. That's 0.015 over 0.005, which gives us an F ratio of 3. Then we need to know the degrees of freedom for the numerator and denominator. For machine A, we had a sample size of 10, so 10 minus 1 gives us degrees of freedom equal to 9. For sample B, we had 12 data points, so 12 minus 1 gives us 11. Back in Minitab, we'll go back to Graph, Probability Distribution Plot, View Probability. It remembers that we're doing an F distribution, but we need to change our numerator, degrees of freedom to 9, and the denominator, degrees of freedom to 11. In the options, we again have an X value. This time our X value is 3. We still want a right-tailed test. The p-value this time is 0.04484. 0.4484 is less than our alpha of 0.05. This means we can reject the null hypothesis. There is statistically significant evidence that machine A has greater variability than machine B.